FlowHow, sales of Moldex3D and consultancy, specialists in injection molding simulations.
Hello, Mads Jespersen from FlowHow. In this video, I want to show you how to set up how I would set up an analysis for Moldex3D injection molding simulations. I'm using Moldex3D release 14 service pack 2. I'll start with a new project. I'll just call it test. Hit OK. Yeah, there I have another one, but I'll just override it. Then starting up a new run. Normally I better like a white background, and I can change it by this button. I can give it some name or some this run. I go to the mesh, find a new mesh, and I know I've done a mesh here like that. Then I have a mesh here, or a model, with some mold box and some cooling channels. Oh, it's then I want to put in a material, and I use a new material. I go to the user bank. Yeah, I can use this material, a PhD, add to project. Okay. Do I want to put it into the user bank? No, thanks. Not this time. I'll close the material file. I'll start up the process, new process, and then I'll define. I use the CAE mode for this, and I'll give it a 5000 bar. That's 500 megapascal. That's the definition of the machine. How much pressure can it deliver? And then I have to define which packing pressure I want to run with, or give the machine a packing pressure. In this case, I'll say the machine has 1000 bar packing pressure possibility. It's quite a small part, so I know I will not get up to 1000 bar. Next, filling time. I'll put 0.1 is very fast. No machine can really deliver fill up a cavity on 0.1 of a second, so I'll put in 0.3. I'll put in there's a straight line of the profiling of the filling, and if it's straight, it will just run in with constant velocity. You can put it up to 100, but it doesn't make any difference, but then it's easier to understand what it does. The injection pressure can be reduced, but to be able to do a pressure controlled filling, but in this case we don't want it. So yeah, now it runs it. If it hits 3500 bars in the filling, then it will not raise the pressure anymore, but it doesn't matter. I will just adjust it for 5000. Then we have the 5000 in the injection. I'll change this for exclude runner, because a small part on the runner is nearly 50% of the full volume. The switchover point is then defined of 98 percentage filled by only the volume of the cavity. The packing time I'll put in quite long to be able to define. It's the first run, and I use the first run for defining the real packing time. So to be able to define the packing time, I will use a long packing time in the first run and look at the intermediate results and find the real packing time in the next run. I'll change this for machine pressure. Otherwise it uses just the injection pressure as the pressure in the packing. That's not what I'll do. I'll use a fixed pressure, which is normal, and I'll define the fixed pressure here. I'll run this with 350 bar. That's 35 megapascal. And the melt temperature and the mold temperature, they are from the material data, so I'll just use those. Advanced setting, I'll use this automatic heat transfer coefficient, and if there's a tendency to short and it doesn't fill within the time that you have defined, you can make the time longer here, so you actually give Moldex the possibility to fill the part, even though it cannot fill it within 0.3 of a second. In this case, I'll bet there will be no problem, because I don't have a very small wall thickness or very high density material. In the cooling, I'll change to transient cooling. I'll change the cooling time to 10 seconds. I'll change not the mold opening, I'll keep it on 5. Then I'll go in for the cooling channels. I have 2 cooling channels, 1, 2. I can switch them on so you can see them there. And then I define the flow in the cooling channels. It's around 5 liters, and that's 80 cubic centimeters per second. I'll copy that down to the other. Okay, I'll go into mold material, find a mold material I want to use. I think I'll use this one. Okay. Estimate the cooling time I don't use. Then I have a cycle time of 25.3. It's quite long, but it's the first run to define all the parameters for the next run, so I have in the next run the right cycle time. I'll finish this, and then I have a process for this. The next step is the computation parameters. I use the customize with the compressible flow. The only difference between the standard and the customize is that you have possibilities of tick marking the compressible flow. The compressible flow gives more precise calculations about the pressure and so on, but it also takes longer time. So if you want to save some time in solving, you can use the standard solver or standard analysis. Intermediate results in the filling, I'll do here. I'll split this in 3, so I need 2 more results. I have the end of filling result, and packing time is between 1 to 10 seconds. I'll split that in 20, but I have the end of pack results already. It's always there, so I'll put in 19 and enter, and OK. I'll run with the estimate required cooling time. Then I have a simple cooling results in the filling. It's only defined on the material, defined as which material you're running and which wall thickness you have in your part, and a constant mold temperature. Predict gate freeze criteria, I'll take off. Run with fiber orientation. It's ticked on when if I have taken a material with fibers. Well line particles, I'll use that normally. If you have weld lines, you can see some particles appearing in the weld line, and you can see if there's underflow in the weld line. Extend packing I'll take off. In advanced, I'll normally run with customize with 1, but a default flow solver is fine. This I'll never change. Venting and wall slip is I'll not mention something about those right now. The next one is the cooling. if I'm interested in the more detailed calculation of the cooling water, I can tick this one on. And if I have conformal cooling, I can also use this run 3D solid cooling channel analysis for more precise flow in the cooling channels. Cycle average, I'm never change that, but now we have a transient analysis, and I want some results of the temperature during the cooling phase. So I'll go into this edit, and I'll split this in 20. So I have the end of cooling result already, so 19, and I get results every half second. And the opening time is 4. Then it does the same just every second. It's possible to save a template of this, so you don't have to change it every time. You just tick this on and say OK. In the warpage, I use the standard solver, linear, and remove runner and calculation. Consider in-mole constraints I tick off. Solver acceleration I use. Consider in-mole consider flow introduce residual stress in warpage analysis, normally not ticked on. Then I tick those two results on, and consider viscoelastic material property in warpage analysis I also do not tick on in this case. Now we actually managed, I think. We're ready to run the analysis. I say finish here, and I double click on the analysis, or I can go up to analysis here and then I find the analysis I want to run. It's the transient. I start out with a transient cooling to define the real mold temperatures before starting up, and then I use a fill, pack, cooling, and a warpage results. Sorry, there, run now. Sorry. There was one thing I forgot to change. I'll close. I'll go in, double click here, modify, go to computation, view edit. I'll go to the task manager. In this case, I want to run it locally on my machine. I said it should run on the server by this computing manager, but I'm not connected to the server right now. So finish. Let's see if we can do it now. Run now. And it starts up the analysis. Thank you for watching the video, and have a nice day.